All right, so talking about two things today, one of them being GCF, the other one being LCM. So when I say the letters GCF, we're talking about something called the greatest common factor. So remember, factors are numbers that we multiply together to get a product. So we're looking for what is the greatest number that we can divide evenly into two different numbers. So the biggest factor that two different numbers have in common. And then when we talk about LCM, that is the least common multiple. So the least common multiple, or the LCM, is the smallest number that is a multiple of two different numbers. So remember, we can find multiples by skip counting. So multiples of 2 would be 4, 6, 8, 10, 12. Multiples of 4 would be 8, 12, 16, 20. So with LCM, we're looking for the smallest multiple of two separate numbers. So let's compare the numbers 12 and 30. Okay, now we're going to use what we know about prime factorization and breaking down these numbers by factor trees, all of their prime numbers. So remember, lots of different ways that you can break down a composite number sometimes, but you should always get the same prime numbers as someone else who solves it a little bit differently. So I have 12 here, and I can break down 12 into the number 6 and 2. 2 is a prime number, so I'm going to circle it. And then 6 I can break down into 3 and 2. 3 is a prime number, so I circle it. 2 is a prime number, so I circle it. Once I have all my prime numbers, I'm good. My numbers is broken down as far as I can get it. I'm going to break down the number 30 into 3 and 10. 3 is a prime number, so I circle it. 10 is a composite number that can be broken down into 5 and 2. 5 is a prime number, 2 is a prime number, so I circle it. Now, what we use to help us find GCF and LCM is a Venn diagram. So I'm going to label the left side of my Venn diagram as the number 12, just because I already have 12 on the left side. So we'll make 30 the right side. So what I'm going to do is I'm going to write the prime factors of each number. I'm going to start with the ones that they have in common, the ones that they both share. So I see that 12 has a prime factor of 3, and so does 30. So I'm going to cross those off to say, hey, you've already used those. I'm going to put a 3 in the middle because they have it in common. 12 has a 2, and so does 30. So I'm going to write it in the middle. But then 12 has a 2, 30 does not have an extra 2. So that leftover 2 belongs just to the number 12. And then 5 belongs to 30, but I don't have the prime factor of 5 in the number 12. So 5 just belongs to the number 30. So here is my completed filled out Venn diagram. So again, when I look up here at my factor trees, I cross off the ones that they have in common, and I leave the ones that are specific to that number, I leave them uncrossed, and they go on the appropriate side. Now, in order to find the greatest common factor, I'm going to look at the center part of my Venn diagram where they see the ones in common. And what I'm going to do is I'm going to take those two factors and I'm going to multiply them together. So 3 times 2 would give me 6. So the greatest common factor of 12 and 30 is the number 6. To find the LCM, I need to take the factors that belong to 12, the factors that they have in common, and the factor that belongs to 30 and multiply those all together. So 2 belongs to just 12. I've already multiplied my common ones together, so 3 times 2 would give me 6, and then times 5. So I have 2 times 6, which would give me 12, 12 times 5, which would give me 60. So 60 is the least common multiple of 12 and 30. Let's try 2 more together. Okay, this time I have the two numbers 54 and 45. I'm going to start with 54. I can break 54 down into 9 and 6, both of which are composite numbers, so I'm going to continue breaking it down. 9 can be broken down into 3 and 3. 3 is prime, so I'm going to circle those. I can break down 6 into 2 and 3, which are both prime, so I'm going to circle those. Then I'm going to break down 45 is 9 and 5. 9 is a composite number, but 5 is a prime number, so I'm going to circle it. And again, I can break down 9 into 3 and 3. 3 is prime, so I'm going to circle those. So again, I'm just going to keep the left side 54 because it's already on the left, right side 45, and then let's start with the things they have in common. See, 54 has a 3, so does 45. So I'm going to cross those off, write a 3 in the middle. I see that 54 has another 3, and so does 45. So I'm going to cross it off and write 3 again. But then 54 also has the prime factors 2 and 3, which I don't see over here on 45. So this 2 and this 3 just belong to the 54. And then 5 just belongs to the 45. So remember, to find our greatest common factor, we're going to take the two factors that are found in the center of our Venn diagram and multiply them together. So 3 times 3 would give me a greatest common factor of 9. And then when I do my least common multiple, I'm taking all the things on the left. So 2 times 3 would give me 6, times what's in the middle. 3 times 3 would give me 9. And then times whatever's on the right, and that's just the number 5 this time. So in my mind, it doesn't matter what order I multiply in. So I start by doing 6 times 5, which gives me 30. And then I know that 3 times 9 would give me 27. So add a 0 to it would give me a least common multiple of 270. Okay, let's do one more together. I have 72 and 90. 72 can be broken down into 8 times 9, both of which are composite numbers. So I'm going to continue breaking them down into 4 and 2. Now 2 is a prime number, but 4 is composite, and it can be broken down into 2 and 2. 9 is composite, and it can be broken down into 3 and 3. And I finally have all prime numbers. And then 90 can be broken down into 9 and 10, both of which are composite. 9 can be broken down into 3 and 3. 10 can be broken down into 5 and 2. So I've got all my prime numbers again. Put 72 on the left, 90 on the right. So I'm going to start. I have 1, 2, and 72, 1, 2, and 90. So they share that 2. But then I've used all my 2's over here. So I see that these other 2 2's, because that's not confusing, these 2 separate 2's just belong to the number 72. Okay, I see that 72 has a 3, and so does 90. So they have that in common. 72 has another 3. 90 has another 3. They have that in common. So the only thing I have left that belongs to the 90 is just the number 5. So to find our greatest common factor, we're going to take the numbers in the center, multiply them together. So 2 times 3 times 3. 2 times 3 would give me 6. 6 times 3 would give me 18. So the greatest common factor is 18. The least common multiple, LCM, 2 times 2 would give me 4, times 18, times 5. Okay, again, it doesn't matter what order I multiply in. So I know that 4 times 5 gives me 20. 20 times 18 would give me 360. So a least common multiple of 360.